So we were talking about classes in the last session, and we're going to continue that discussion in this session as well. Okay, so just a quick thing on what we talked about. We saw how to declare a class, right? We saw how to define a class, and we saw the init method inside the class. So init is what initializes a class. If you don't provide it, that is fine. Python uses a default one. But if you want to do a custom initialization, then you provide this. For example, you're creating a person class and you want name to be provided as the initialization code, then you will put an custom in it. And the first argument here was self. Then you put the rest of the things. We looked at the class methods, and also we created few classes. So let's just quickly browse through the few classes we created. First, we looked at my class, some simple value, essentially just creating some random class with some x and y values. Then we created a person class, and today we're going to extend this person class. So the person class had an init method which took name, and then there was a last name method that gave the last name as the answer. Okay, so finally we were working on the queue. I created a custom queue. So queue exhibits this first in first out behavior, right? We call it FIFO behavior, first in first out, in which when each item enters, let's say the item number 1 enters first, then item number 2 enters, then inside this collection, they are kept in a way that when you try to dequeue, the very first item that was inserted is removed. So the item that goes in first comes out first. So we implemented that using an array. So every time we were inserting into array, we were inserting from the 0th index. But anytime we wanted to remove, we were removing from the last index. So this essentially gives us the behavior that um, elements are going in one end, coming out of another end, and hence you have a queue, essentially. So we were here, and it's time to do some more operations on this. Okay, but before we do that, let's import this queue inside our terminal. So what I'm going to do is I'm going to open terminal program. Okay, I think I have some class which is messing this up. What is this? Let me find the name of this class and fix this. Or actually, let me run this from a different location. Suppose I have this, and basically let's create a package called my package, and sorry guys, just give me a second, and then move q.py and do that my package. All right, now here inside this cd my package, let's open the Python terminal. So I have created some kind of a file in my downloads directory which is messing with the Python initialization, so I'll have to find and delete it. But we are here, and I'm going to say import queue. So once I do that, give me a second. I was not expecting this. Let me see what is in the queue class. We have a print method or something, I think, inside the queue. Just give me a second. Let me fix this. let me fix this real quick. We have some print message, I think, in the queue, and then let me make this better, and then we will try to play from the main terminal. So let's just get rid of this. Okay, now let's go back to the terminal. I think it should work fine now. Python 3 import queue. All right, so it's here, and we have a queue, which is a module. Okay, and if you do a dir on this queue right now, you will notice that this queue has something called, so this queue is the module itself, right? And if you want to access the attribute inside this queue, let's look at the code, how we define this. I did a mistake while declaring this. This should have been caps, because that's the class naming convention. It should be caps queue. So what I'm going to just do is I'm going to exit again and just come back and just import queue, and now dir on queue. We do a dir on this queue, and you will notice that we have a queue attribute. So now if you want to access that queue, let's say you want to create an object of queue, and you try to do, let's say, queue equals to queue, then problem, because the queue name is not visible. We just imported the module. So instead, what you have to do is you have to say from queue, import that attribute. So, or you do queue equals to queue dot queue. That's the other option. You either write this, or if you want to just write queue equals to queue, then you'll have to import the queue like this. All right, so once you have this, let's write this. So you have queue now. So let's just say, okay, queue dot nq. I believe that's the name, right? Q dot nq. Sorry, I used the short spelling. nq5, then q dot nq, let's say 6, then q dot nq 100, and q dot nq, let's say 5. Then we write q dot dq, then 5 will come out, 6 will come out, 100 will come out. And then we have written it in a way that basically once it's empty, it's returning none right now. So just like any other built-in function, we are live playing with our object at the moment. So once again, we insert, let's say, q.nq100 and nq5. Suppose we are in this position and we write q, then this shows us the object. Or if we write print q, if we say like print q like this, then this shows us whatever, the same thing. Now, how is it that, so the discussion will begin with this point, that how is it that when we define a list and we say print L, it prints the list. It doesn't tell you the address of the list. It doesn't tell you the location of this list. It doesn't tell you this thing, whatever the location of this list is, but it tells you the list itself. And with that, I'm going to jump into the discussion of operator overloading or function overloading. All right, so you can override the default behavior. Okay, so let's name the term clearly. The term is called override. We can override a default behavior, right? So the default behavior on a custom object when you print something is that it will print the whatever the generic Python's understanding of this object is, whatever the string interpretation of that object is. But you want to change it. You want to change it and print something meaningful. And the way to do is that there is a function that we can override. And let's look at that function. Suppose I do dir on the queue type of class. Then what you will notice is that we have defined this. The trick to do our custom operation here is that to change the default double underscore str function. Double underscore str function is what Python uses to print anything. So suppose that you have a list of some form. Suppose you have a list, which is, let's say, 1, 2, and 3. This list is a type list. So when you say print L, the first thing that happens is Python will check, okay, check for custom definition of str function. Is the str function defined in this particular type of class? If this is defined, yes, then use this. If it is not defined, then use default. Right? So essentially, we can list class when it is written, it overrides the double underscore str method. But we have not overridden. So what I'm going to do is I'm going to show you how to override a function. This we will explore now, and we will then also explore when we talk about inheritance in the coming lecture. So let's override that function. And in order to override, you don't have to do much. All you have to do is you have to define that function again in your module. So I'm going to say def, and I'm going to say underscore underscore str underscore underscore, and then self. No argument goes in this. Okay. You just override the definition of str. When the print function is going to print your custom data type, when you say print of, let's say, some q, print function will internally call the underscore underscore str method, and it will expect that this calling of this str method will return a string type of object back. And then print will simply take that and print it here. Whatever comes out, it gets printed on the console. But the important condition is this str. If this return type is not str, if it's none or int or something, then that will result in some kind of an error that will lead to error. Okay, so important thing is that we define this str. So suppose I come here and I say return my custom print. Suppose I save this. What I'm going to do is I'm going to reload this module just for the demonstration purposes. I'm going to reload this module. So I'm going to say import and reload reload queue. Okay. Actually, let's not do this. Let's do the normal way. Okay. Python 3 import from queue import queue. And let's define a queue. Let's say queue is equals to queue. And once again, queue.enqueue of 5. Now write print queue. So when you write print queue, essentially, you will get a message custom print. You will not get the message that you will earlier seen in the previous console screen where you were saying print queue like this. You're going to get your custom behavior. Okay. And what I'll do is I'll actually develop right here. So it will be easy. I'm just going to say queue equals to queue and print queue. You can just basically enqueue some items here. 5 and 100 like that. And then we should say print queue. So once we do that, that's our custom print. Now what you have to do instead is you want to, let's say, print your list, right? So the way you will do it is that you will have to return the string representation of your list. So what is our queue right now? The queue attribute is self.queue. So all we have to do is take self.queue and cast it into a string. Let's just cast it into a str. And then we just do a print queue. So this is our queue now. And then we can add something more. Suppose let's just repeat this call a few times. This, and let's say this. So this becomes, let's say, 50. And let's say this becomes 25. And then you have one bunch of q.dq. And then again, print. And this few more dequeuing operations. Then when you run this code, essentially you will notice that this is how our queue is growing, and this is how the dequeue is happening here. So as you can see, we are now doing a custom print by simply overriding an str function. And we will see the same behavior in the terminal shortly. Any questions?
But we are not calling the method underscore str, right? So I'm a little confused how we get
Print
that.
is calling it. When you write print q, print is internally, so I mentioned here, when you say print internally calls str.
Right. Oh, okay.
Str. And this has to return a string back so that print can print it.
Okay, makes sense. Okay.
Yeah. Although there's one more thing. So remember how when we do print q, it's printing custom print. It's printing custom print because the module is already loaded. Python does not know that the change has already occurred in this. But just taking an example from here, if you have a list 1, 2, 3, if you write print l, you will get 1, 2, 3. But if you write l, you will still get 1, 2, 3. Whereas in our method, when we write print q, this gives us this, but when we write q, we still get this object. So when you're playing in the terminal, this just writing the object is not printing the behavior, the actual attribute that we want to print, but it's printing its default. And the reason is that when you are in the terminal situation, which is a print, which is a read eval print loop, essentially it is not checking this method, but it is checking another method, which is called representation, string representation of this. That's what it's checking. To just when you just write the object itself, just when you type the object and you hit enter in the terminal, this method is checked. Okay, how to represent this object? And this method is also supposed to return a string back to the terminal. So once we have made all of our changes, let's go back to the terminal, exit and come back. Okay, from queue, import queue. And because we already have this, these print statements are there in the module, that's why they're printed. So now we come q equals to, let's say, q of, and then we say q dot nq 100. Now if we just write q, you will get our behavior. We say, let's say 50 q. If we write, let's say 25, we write q, we get this. Similarly, when we do q dot dq, the dq is returning the value it got printed, and then finally q is this. If you write print q, then also it will do this. So we are changing the behavior of print and how the object is interpreted inside the interpreter by overriding the behavior using by overriding the behavior of str and repr. So this is the string and this is the representation of the object. I'm going to give you a minute if you want to try this out. And if you don't have this module with you, then you can just write a simple class, a very simple class. For example, this one. And you can just, let's say, define underscore underscore str and self. And basically you can just write return x comma y and str of that. Now let's say if you did print a and b, we already have print a and b. Let's see what it prints now. Let's get rid of this. Let's get rid of this. When you do this, you will notice that, okay, my mistake. Self.x and self.y. On this str argument, what happened? Return str self x self. What am I doing? Yeah. So the reason this is not working is because now it will work, because now it has to be a tuple. So this is one object, not two arguments separately. This is one tuple that we are casting into an str, or just, if this makes sense, this is the tuple and we are saying str of t. So we run that. 5, 10, and 100 and 100. Take a couple of minutes and try this out yourself. And if anybody has any question, you can ask me the question as well.
Can you one more time explain what is REPR? Sorry, I didn't get that.
Yeah, REPR is the representation. So suppose that you are on this console here, okay, and you say that this dictionary is equals to this. Next time when you are in the console, this is the read eval print loop. This interpreter essentially is reading, evaluating, and printing. Next time when you write D, just by writing D, how does interpreter know what to do? When you write it, it will give you this answer. But how does it know what to do? What it does is that it checks a method called REPR. It checks if this method is defined in your object, in your class. If it's defined, then it will use this function to print. If it's not defined, then it will go to the default value of printing your stuff. So if you just say define some random class, you say class person, and you say whatever this random class, and you say p equals to person. Then if I write this p, notice when I wrote this D, this printed the dictionary. If I write p, then Python now does not know, because we have not told Python how to print this using an REPR method. So it will just go to the default representation of that object. Does it make sense?
Yes, thanks.
Okay. So yeah, once again, take a couple of minutes, try this out yourself, and then I will move to the next topic.
Could we import something that's in a different directory?
You can import something that is from a different directory. Yes, Graham. And it's coming up, okay? Basically, when you have packages, you can say from this package, which is in some other directory, import here.
What are the steps to reload a module?
When you want to reload a module, you will have to import a module called IMP. And this from IMP, you'll have to say import reload is the function. and then you will call reload and then parentheses something. So you will do this step. I'm not going to run this because my setup is slightly problematic. So you do reload and then whatever you want to reload.
To me, it says that this INP is deprecated in favor of import lib.
So looks like, yes. I have not tried this for a long time, so I need to read the documentation. Probably there is something which is the new thing that Python is proposing instead of using this. This used to be an old thing. I used it in past. So probably I need to refresh my knowledge. So in the world of operator overloading, we are going to tell Python how to perform a certain operation based on the type of your object. So in order to do this, okay, let's define a new type of a class. I want to define a new type of a class, which I'm going to borrow from the mathematics, world of mathematics, and it's called vector. If you don't know what vector is, doesn't matter. Just understand this, that vector are physical quantities which can be represented as two items. Okay, so for example, you can write vector v1 as 5i plus 2j. And you can write vector 2 is equals to 2i plus 3j. Assume this. Then if you write vector v1 plus v2, then v3 becomes you sum the I values and you sum the j values. So this is essentially v1 plus v2. So j is added separately and I is added separately. Okay, so this is a two-dimensional vector, 2D vector. Once again, no need to worry about the term vector if you don't know, but I'm just telling you this is a data type that we're going to create. And at the same time, you can multiply a vector with a number. You can say v1 multiplied by, let's say, 5. This means that 5i plus 2j is supposed to be multiplied by 5. That means 5 is going to be multiplied individually to these two. So this will result in 25i plus 10 of j. So I'm going to create a class which will represent a vector, a two-dimensional vector. And we will implement an operator overloading on this such that we can add two vectors and we can multiply a vector with a number in this example, right? In this vector, we have two quantities. We don't worry about I and j. I and j is for the human readable format. We will print, when we print, we will just append I to this and to j to the 2. All we worry about these two quantities, 5 and 2. So the vector can have just two values, x and y, inside, like self.x and self.y. When we are printing it, we will just add I and j as a string in the end. So I'm going to define a vector class. Okay, so let's begin. Let's save this as vector dot py. Okay. So I'm going to define a class called vector, and I'm going to visit this as a reference. So vector has two quantities. This is a two-dimensional vector. It has two quantities in it. So first I'm going to define the initialization method. And suppose it takes in two values and I'm not making them default value. That means whenever you create a vector, you will have to supply those two values. Okay, so unlike, for example, here you notice that these are default values. If you don't supply them, as in the line number 16, they continue to work. But in this case, it will not work. I'm making them positional arguments. So I'm going to say, okay, there is an instance variable called self.x, which should be equals to x, and then there is an instance variable or attribute, sorry, called y, which is equals to y. And let's just define the str to begin with so that we can start playing with this thing. So we can print it comfortably. So now what we have to do, we have to say self.x. Okay. Now remember, str has to return a string. Okay. X is a number. So we'll have to say str of this guy. And what I'm going to do is I'm going to just simply do a string formatting expression rather than writing this code. For example, I was planning to earlier write this code. Str of this plus I plus something plus j. Instead, what I'll simply do is I'll write a string formatting expression of this form. I'm going to say this I plus this j. It's going to be much more neater that way. And then format, put the value of self.x and self.y. Python automatically is going to cast this into a string and then just return this string. Okay. Now I'm going to create a vector. I'm going to say v1 is equals to vector of 5, 2. And I'm going to say print v1. When we do this, notice it prints 5i plus 2j. This I and j is only important for humans. We don't care in the internal representation. We just worry about that there are 2 dimensions, x and y. So we just carry x and y. So we have created a vector class which can be initialized with x and y, and we can print the vector so far. And while we are here, I'll just also as a boilerplate do this with REPR as well. And I don't have to do this. I don't have to repeat this piece of code. I can just write return self.__str__ this. And if you just write, let's say v1 here, and you do this, this is going to work still. Oh, actually, we are in terminal right now, so it's okay. Oh, so we are in the program, sorry. So it's okay. When we go to the terminal, we will see the result. So we are done here now. So now comes the important part. The part that I want to discuss is the addition and the subtraction. How does this addition and subtraction work? The way it works is that we are once again going to override a function. Essentially, in the case of operator overloading as well, we are going to override a function. And to understand that, let's look at the str module. And let's look at the add function. Add function is what is used to define the behavior of the plus on an object. And similarly, as you might have noticed, the mod is used to define the behavior. Oh, sorry, not mod, where is it? Multiply is what is used to define the behavior of multiplication on an object. If we override this, then we will be in a good shape. If we override these two, we'll be in good shape. So if I, let's say right now, import, this is from vector, import vector, and I do, where are we? Vector, is it a path problem? Okay, I probably, just 1 second. I'll do this after we define, that's okay. So we are defining this and save it as, I thought I saved it in my package, but I did not. So let me save this here. Vector.py. So from vector, import vector. So when we do dir of vector, Notice that we don't have that add function here, just like we did when we did the dir of str. There was an add function here, and that is what is making the difference. Python does not know how to add two vectors, and it is giving you that error, and there is no default implementation of add in this way. So what we're going to do is, let's define the add function. Def _add _, and let's say it takes the first argument as self. Now, in order to add something, you need two arguments. The first argument is going to be self itself, that Python will pass. And the second argument has to be something that Python will use on the other side of plus, the other operand. Let's just return, let's say 100 for now. Don't worry about this. And create another vector. v2 is equals to vector of 2i plus 3j. Okay, so let's just say 2 comma 3. And also let's say print v2, and then print v1 plus v2. So when you do this, it will just return 100. Now, a quick word of understanding here, so how this is working. When you're doing this v1 plus v2, okay, this is an operator, not a function. Just to keep that in mind, this is an operator and not a function. And furthermore, you can also add another operator like this to another operand. And I will show you an example shortly. In this binary operator here, basically you have two operands, left and right. So when you're defining this function here, you will write self, which is the current object, and the other, which is the second object. Python is going to pass v1 as the self and the v2 as the other. So when you try to sum these two, remember you need to add the x and the y separately. So I'm going to just create a variable, local variable called x is equals to, let's say, self.x plus other.x. And then y is equals to self.y plus other.y. And we can just return xy. That will not work. When you sum two vectors, remember there's another important aspect, important thing to this is that when you have two strings, ABC plus DEF, when you add these two strings, there is another string that comes back. So you concatenate these two, and then there's a third string returned. Similarly, when you add two vectors, a third object is going to come out, which is going to be a vector. It is not just some print of a string. So with this x and y value, I'm going to construct another vector object. How do I construct another vector object? Like this. I'm going to construct this vector object and say it should be constructed with x comma y, this x and this y, and return that vector back. So first compute the x, then compute the y by adding the x and y of both the arguments, both the operands, and then basically return a new vector of this form. Let's run this code. Now notice that this is the third vector. And it can be proven that it's third vector because if Python is smart enough to chain this as well. So for example, suppose there's a v3, which is a vector of, assume that this is 3, 10. And you write v1 plus v2 plus v3. When you do this, when you run this, this will continue to work. How is this happening is, when you write v1 plus v2 plus v3, Python starts here with this plus operator and it says that, okay, these two are the operands. And it goes to the add definition, how to add these two things. Once it sees that, okay, there are two operands, left and right. So the v1 and v2 are added and a new vector object is created. So this returns a new vector, which is then added to v3, which returns another vector. And that vector is getting printed here. If this was not a vector object, then you'll have a problem. It will be like type error. So we are seeing a behavior where we have added the functionality to a plus to a custom type. The custom type is our vector type. And we can now plus add it the two vectors just like we add any other thing. I'm also going to add a multiplication to this. Remember, we can multiply a vector by a number. You can also multiply a vector by a vector if you want to define that way. But I'm just going to say vector by a number, and I'm going to give you an assignment after this. Okay, so I'm going to now override the multiplication. Self comma x, or let's say self comma whatever the number of times you want to multiply. Okay, so a. So a here is 5, and this is the vector. So we're going to construct a new vector, and this vector's x value is going to be self.x multiplied by a. This a times of this. So for example, 5 into 5 is 25. So this is x self.x multiplied by a. Similarly, y is equals to self.y multiplied by a. And then once again, construct a new vector with x comma y. Now let's try to multiply the vectors. Okay, so suppose you did this, and now let's say print v1 multiplied by 100. When you do this, vector object has no attribute t. What did I do? Oh, sorry, I messed up. So when you do this, now you have the multiplication on the vectors object working fine. So we have just customized the behavior of multiplication for our object type. And this is very powerful stuff. And you see in how many lines we're able to accomplish this is just ridiculous. Like we just wrote 2-3 lines to do this. Right? So we have just created a complete 2D vector for our use, right? The 2D mathematical vector. Now there is in vectors, there is dot product, cross products, and all those kind of things. We can also implement that if needed. Let's import this vector into our terminal to play around with it. Okay, I'm going to say from vector import vector. Now first thing is, let's do a dir on vector. Now notice that this add and the multiplication has been added, and few other things have been added to this. Let's create a vector class. Okay, we're going to say v1 is equals to, let's just copy this from here, whatever we have. Let's say v1 is equals to this guy, and v2 is equals to this guy. So let's first say v1 plus v2. Right, so we can just sum it how we do it on list, and let's print v1. Just by writing v1, we are able to see the value of the vector, and this is accomplished using the representation function, REPR. And then we can write v1 plus v2, and then we can also, let's say, create another vector here, this guy. Now we can write v1 plus v2 plus v3. We can write v1 plus v2, and then we can sum that. v1 plus v2, remember, when we do this, is returns a new vector object. So that vector object can then be multiplied to something to get an answer. Right, so complete arithmetic started working with our custom data types now. Any questions?
Can you give some examples of operator overloading, like where it can be used in?
So I'm just showed you one example. For example, vector is an important thing in mathematics, right? That, I mean, if you are dealing with any kind of, let's say, mathematical model, you might be creating vectors because you have to do all kind of operations. Suppose you're having, let's say, force, and you want to, all the physical quantities, they are vectors, like force, velocity. So if you're modeling that kind of stuff, you will need vectors to deal with it.
Okay.
Right? And this might be useful for some custom type as well, some general type as well. I'll come up with some kind of example and let you know. So there is one example in Python itself. I don't know if you're familiar with complex numbers. So complex numbers, Python has the capability to express complex numbers, right? And then you can say that, okay, this C1 is equals to this, and then you see C1 multiplied by 150. So this is doing the same thing again. This is a complex number, and the complex number is essentially and has its own arithmetic, sorry, and then it does the same thing.
Okay.
Later on, we will also see some other things. You can also make your custom type an iterable type, and you can, just like when you have a list, you can do this square brackets. You can also do that on your object. We will see that later on. But
yeah, thank you.
So in this example, if you do v1 plus 1,
that will be troublesome.
Okay.
If you do v1 plus 1, then Python does not know how to add an integer to a vector.
Like in complex, it's going to do it because it's know how to C1 plus 1, it will add automatically.
Yes, because they are handling that case, right? So if you want to do this, then essentially you will have to make your add a little bit more smarter. You will have to check if the other is a number, then basically behave it differently versus when it's a vector. So you'll have to do some type checking there. Does that make sense?
Yeah. So it means that when you call import this function, it only applies the addition that's created in that function. You cannot mix and match with other classes. And
if you want to do that, then you'll have to add logic in the add function. To do that, yeah.
Okay, thank you.
Can you not add multiple add functions like this? Underscore add?
No, you cannot. Once again, in Java and C++, you can have multiple signatures for a function, and they're statically compiled, and the runtime they're chosen accordingly. They're statically compiled and they're chosen during the compile time which function is going to be called. But in Python, there is no such thing as having different signatures.
So you can't overload it, or if you did try to overload it or override it, sorry.
The latter one will take into effect.
Okay.
So that's all I had for today. Okay. And I'm happy to answer any question if you have. Otherwise, I'm done. And in the next session, the one thing that we have not covered that I think we will be covering as we move along is, just to give you roadmap, is first thing is inheritance. Right. So I want to make sure that we understand the concept of inheritance properly, in which an object can inherit the properties of another object. By inherit means that it can automatically acquire the properties of another object, so that you can define types properly, right? So you can say, you can establish is a relationship, right? So you can say a dog is a mammal, for example. So if you have two classes, if there's a mammal class and there's a dog class, you can specify this type of relationship using inheritance. So I want to cover this as well. And then we have some discussion left on packages, in which currently every single module that we are writing is in the same directory. So we are able to import it from there. But I want to show you the concept of package, in which you will have your code distributed in multiple files over multiple directories, and then you will be able to import it in your current working module.
Would you also cover composition, like Haza?
Yes, we can cover composition. Yes, sure. Yeah.
Okay.
Yeah. Quite literally, we actually do composition all the time, but it's just little implicit. It's not very explicit to see, but we do composition all the time. But I will make it clear when we talk about inheritance as well. Okay, what I'm going to do is I'm going to stop the recording.